I'll just give a brief intro about myself. I started developing games around 2013, and initially we started with a lot of single-player games and whatnot. And I still remember the time where I was in Bangalore, and I remember changing my 3G SIM to a 4G SIM, and kind of getting networking done through that. So it was about a time when multiplayer games were just beginning. It was on the mobile phones at least we didn't have a lot of different frameworks and whatnot. So it took a while to kind of get a hang of it. And over the years, from all the clients kind of started demanding single player games, and after a while it went on to multiplayer games. So that's how I got started. And over the years, all the clients want things done pretty quickly, right? They want things done yesterday. So it took time for developing things over time and kind of have like frameworks ready, that we can use over and over and over again. So yeah, that's me. And yeah, multiplayer games where debugging is not just a task, it's actually a way of life. You kind of scratch your head and kind of question everything that you have kind of learned. So I'll be talking about some tips and tricks that I have used over the years for all kinds of multiplayer games, but kind of mostly turn-based, because at least in our country and a lot of these client requests, they kind of want turn-based. I mean, real time is there, but it's a little difficult to come by, and also it's hard to make and kind of maintain. So a lot of the requirements that come in our country mostly were real-time games. So I'll be talking a lot about the kind of small scripts and snippets, code that I've used over the years to kind of have general ease of development. You want peace of mind when you kind of develop multiplayer games, because you don't want to spend a lot of time kind of reinventing the wheel, solves problems that other people have already solved, right? So let's just stick to the basics, use the basic knowledge and idea, and kind of get things up and running. So yeah, let me set the stage. So for now, in our case, I'm using Unity. I guess everyone would be. But yeah, so I've been using Unity for some time, and we need a network framework, right, for any sort of multiplayer sort of scenario. And I tried using so many different frameworks, right? So initially we had things like Shepherds, and a couple of other frameworks. And they were not really, they were robust, but then the code and the SDK and whatnot, I don't know. It took me a while to get used to it. So I kind of eventually landed on SmartFox, which I really enjoyed working with. So with that, and also for any multiplayer game, we need a simple game loop. So what would be a game loop? So let's see, we have a 4-player game, and the server kind of waits for all the players to join, and something happens in the game, right? So we have, anyway, it is a game, so any sort of actions can happen. I did a dice roll, I made a move, I put a card out. So we have that going on, and we have rounds in a multiplayer game. So that would be the loop, right? So you wait for all the players to join, and the players sort of join, and you initiate a turn for a player, and the player do their turns and finish a round and rinse and repeat till we kind of exhaust the number of rounds and we reach a game over screen. So, and of course we calculate score and everything. So this is in general kind of like a multiplayer sort of a use case, right? So we have a game, and this can apply to any sort of games. And of course, it's a multiplayer game. Players will drop in and out as they wish, but of course, we'll have thresholds for that. And yeah, and here would be the things that we would need. Of course, it's a multiplayer game. We need sort of low ping players. Thank God that may or may not happen. But for the purposes of at least what I'm going to speaking about, I hope we need low ping players, or because that's dealing with really high ping is a different story altogether. So that involves with matchmaking and everything else. So that's a different solution. So yeah, and we need a heartbeat, which I'll get to what it is. We need ping pong mastery. And we need a client, a clockwork client. We need a client that can deal with time really well. And we need to solve, we need to learn the art of reconnection, because that is very difficult and painstaking basically to solve for. And we need to do some sort of a smart packet wrangling, sort of like, you keep the packet in check. By packet, I mean, the network packets that we send across. So let's get down to the first one, the heartbeat, right? So every multiplayer game has timers. We have the game time. When a game starts, right when all the players join the game, we may have a game time, and then we may have a countdown time, kind of like counting down to the first round or a first anything. And then we have a round time, and then when a round gets over, we may have like a round waiting time until like the next round. And this goes on and again until we have a game over. So when it comes down to that, I've seen that in many different places, it's difficult to keep track of the time, in the sense, on a server, what's the format of time that you use in the server, right? So a lot of times people would just be doing some datetime.now, where they take the current time, or would simply be counting the numbers like as a tick. So all of this is nice, but for me, at least, what has worked well is the use of timestamps. So we've all heard of Unix timestamps. That's like the number of seconds that have passed from 1970, 1st of January, I guess. But that is actually quite helpful, because it's actually quite robust in a way that you get an accurate representation of time, right, down to the millisecond. So timestamps should be used everywhere for all sorts of your timing needs. When you say game start, you can be like, hey, game started at this Unix timestamp. So for any sort of your timing requirements, right, so you should use timestamps and timestamps only, I feel, when you have, and also you have milliseconds. You don't deal with some seconds. Just come down to the milliseconds, you have that accurate time, and that is possible with Unix timestamps. And also, at least in SmartFox, we have on the code side is Java, right? So we have runnables over there. So where you can just start a different task. We can wait for X amount of seconds, and we can get a task up and running after that second. So when it comes down to that, I speak about grace time. So grace time would be like, we have a game has started, a game goes on for 10 seconds, let's say. And whenever we do a game time, never just keep it on the server like 10 seconds would just be the time. Always add like a grace time to it, and not send that grace time to the client. What I mean by that is, so on the server, the timer might be running for 15 seconds, but when you send the packet to the client, just say the timers run for 10 seconds. What this will help us achieve would be, there are scenarios where a client would do a move towards, let's say, the 10th second, and you have 4 clients playing all together at the same time. Sometimes the packet might not just reach to the server on time, or, and other times different clients would be competing for that same last second. When did I press this button? When did I get the score? Who reached the score up first? So when we do grace times, even though, that would help us accumulate all the inputs from the players, even if they send it towards the last second, right, or the last millisecond. That would mean that even though the time is over for the client, it would reach the server, and the server has got enough time to kind of process the request, and then, move on to the next round. And also, we have, it's a multiplayer game, right? So multiple requests would be coming into the server. So that would mean that we deal with multi-threaded issues. So we should always use thread locks. Let's have this notion of synchronized in Java. And you should wrap all sorts of your requests that are coming from different clients in this sort of a code. It's only because you otherwise deal with sort of issues where 2 clients came at the same time, and we have a race condition where the same sort of a code gets executed twice again, and you would just be racking your head as to, oh, how did this happen? And once if you start using things like, you have a thread lock sort of a system where all the multi-threaded processes are coming together sequentially. We kind of go through them without losing data. So that's synchronized for you. And basically, it's actually good practice to keep use of a lot of these sync objects within your multiplayer games, because you are eventually actually going to deal with a lot of multi-threaded issues, which is a head scratcher. And of course, this is what I was talking about, the a start timer. So whenever you do start a game, you have a game duration, and you kind of add some sort of extra time. You never say that 10 seconds and 10 seconds only. You kind of add 10 to 12 seconds. So you accumulate, you get all these requests from the client. And of course, it helps in cutting off input from the client. So you don't want to have scenarios where server has finished the time, but somehow it has received a request from a client side, but how, right? So if you do this way, the client would cut the input from the clients by the 10th second, and they won't be able to send any more, inputs to the server. So that's essentially the heartbeat, I would say. You need to keep that sort of a time consistent with the game. You use unique timestamps everywhere. And of course, ping pong. What I mean by that is the actual network ping pong. We live in an era of internet. You have all sorts of people coming in from, people would be having 4G. A lot of people do not have 5G yet because the phones don't support the 5G aspect. So you have people, if at least on mobile games, if you're playing, you have people connected on Wi-Fi, you have people connected on 4G, you have people connected on maybe the hotspot of their friend in a hostel room, which is even bad. So yeah, that's the main issue with networking, right? So you have different people with different connection bandwidths. So kind of various methods are there, that you can keep track of the time. So ping pong is basically what you mean. So it's a time that it takes for a packet to go and then come back. It's the whole trip time. And that's what we should account for when we make multiplayer games. So this is a simple routine. This is more or less sort of a, It's just a small protocode, you can say. So this is a sort of a routine that you can use on your client sides, right? So kind of get a ping. Of course, the various different frameworks that we might use may have different sort of, internal functions which would tell, hey, here is the current ping and whatnot, which is fine, you can use that. But of course, it is also good that you keep your own sort of a ping management solution, right? So you kind of, basically, I would send a packet. In that packet, I'll keep my current time, which from my clock, and then I would send it to the server, and server just looks at it, sends it back to me, and now I see my time, and I see my current time, and I kind of do my calculation, and that's basically how we get some sort of a ping, This is the sort of, on the client side, that's what we would be doing, once we get the ping request, ping packet back, we sort of calculate the round trip time, and then you get a whole sort of a ping amount, and then you rinse and repeat. You keep pinging the server. And yeah, up next, it's the client. So clients always need to know what is the current time. It is a thing, basically, where, many parts of the game have, let's say in the client, you have a lot of timers going on. So you receive a timer, you have like a turn, you need to show, let's say, on your UI, some sort of a clock that's running. You have maybe 4 different UIs that's going on. You have a lot of different timers. And if the client actually doesn't know the actual notion of a time, then it becomes difficult. You might notice that when you start your game, the game screen sort of starts 1 second late there, 2 seconds late there, maybe a second early on a different screen. And it may not always get in sync, when you have a time that kind of gets over, and then like, hey, why did it get over fast for you sooner and not for me? Like, that sort of a deal. So to kind of deal with all of these issues, you need to have some sort of a good functionality where on the client side you can calculate these things pretty well. So any and all packets, right, that you may send from the server, keep sending the current time of that server along with the packet. So on the client side, I can kind of receive that and do the necessary calculations. So over the years, I used various different SDKs, right? So you have Photon, you have Unity's Netcode, you also have SmartFox. So they all kind of calculate time and the current time a little differently, and this function, this is something that I've been using for quite some time, where every time you get a packet from the server, you send the timestamp to this function, and you sort of get your current timestamp, which is on the client, and kind of get the ping, adjust it for your ping amount, which I spoke about sometime before, right? So this is how you would kind of, in general, for the purposes of your multiplayer games, you can keep track of the time in your client like so, and this works really well for the most part. And you have the art of reconnection. So yeah, I guess to have reconnection working well, you need probably 6 fingers, because that's how tough that is, I feel. So yeah, when it comes down to reconnection, so let me put it this way. Why is my score wrong? Oh, my time is not right. Everything goes amiss. So it is a little difficult to kind of deal with reconnection, specifically when you have multiplayer games where so many 4 players, maybe 6 players, they come in and out, and it becomes really difficult to do kind of deal with that. So you have all sorts of network disconnects, right? So you have Wi-Fi and data switching, and sometimes the code just like pukes. It will be like, I don't want to work. So then you would be like, okay, what's happening? So you have to go through all of that and kind of figure out, oh, how do I reconnect back, right? So a lot of these frameworks that we do use, they already come with their own sort of solution. They have these callbacks that'll say, hey, subscribe to this, maybe a function which says, hey, this is a player is dropped or a player is joined, and things like that. Of course, these are good, you should use that. But I think on top of that, it is important that we kind of keep track of our own we have our own sort of a solution to handle reconnection and disconnections, right? So, of course, on the server side, you should keep track of all your players using a structure, maybe similar to this. So this will say this player is disconnected, this player is forfeited, what would be the player ID, what would be the player's name. So it's quite important that you have a structure like this on your server side to deal with all your player data, instead of just relying on the standard callbacks that a server may or may not give, or even on the client side, which would say, hey, I've got to disconnect, or hey, I've joined into the room or into the lobby and things like that. So, and of course, you should write your own explicit sort of user disconnection system, right? Instead of just relying on all of these different things, have your own sort of a system and keep some thresholds with that. So, at least on the server side, here is one thing that you can do, right? The client can always send a ping. The client is anyway sending a ping to the server, like how I was telling before, right? Just so that I can calculate my trip times. So as and when the server gets the ping, you can always have a system where I keep getting the ping, and the client probably sends the pings to the server in some sort of a frequency, right? Maybe every 1 second, every 0.5 seconds, it can vary. So what you could do is, every time a ping comes into the server, you can sort of manually initiate a disconnection request of the client. So basically, that would mean that I am the server, I get a request, and then I can be like, hey, if I don't receive the ping from the client in the next 5 seconds, disconnect the client. Like, don't have to wait for a disconnection packet from the client and whatnot. If I haven't received the ping, cut them off, right? So that will make sure that you have a whole loop in your game where, if you stop receiving the pings, that player is disconnected. And inversely on the client side, you can have your own logic to kind of handle these sort of things. And yeah, so that's one basically sort of a disconnection function, right? So I get a packet, I schedule a function for the next 5 seconds to disconnect the client, and then within under 5 seconds, if I get another ping, I can just cancel this thing and do it again into the future and this kind of goes on. So yeah, this is a similar thing on the client side also. You should do the same thing where if the ping from the server hasn't come in an X amount of second, then I disconnect myself. So that way I trigger my sort of, on the client side, you have your sort of a disconnection code and all these sort of different callbacks. You can do that. You can cut the client's connection if the ping itself is not good. And then go through your whole disconnection sort of a loop. So yeah, that was one major thing as in when it comes to reconnections. If you have those things ready, I think more or less you're sort of multiplayer, at least reconnection for that sort of this sort of multiplayer kind of games, I think works well. You have a robust solution. And then the last one, I guess, would be packet wrangling. You need to be really careful about what sort of data that you pack in your packet, right? So you make sure that you send only and only the data that you need in your packet. You can use bytes. If you have to deal with numbers, let's say, just don't use floats and double and long all the time. Just if you want to deal with a number, if it's under 10, maybe use bytes, something like that. So packet issues might not be an issue for you in the initial stages of your development, because all of this kind of bites you back in your ass when you kind of scale up, right? So when you have large number of players, you have a server that's running on money. So you need to be sure, okay, my packets are small in size, I don't run out of my server space, I don't run out of my processor space. So all of these things you have to, as a programmer, you have to keep it in mind at least, because at the end of the day, the business has to run, so your code directly affects the business. So you need to make sure that your packets are small and do anything and everything to kind of make everything work, let's say in a 2G network, if that is the thing. And of course, make sure you use HTTPS. That's a standard thing, but just to mention that. And try to compress all sorts of data that you may or may not have. So this is just a simple function that I have been using for quite some time, where you have, let's say, you have a lot of game data, and you kind of JSON, you make a JSON out of your data. Now you are left with a string. Now what do you do with the string? You don't want to send that string across the network just like that, because, of course it will go off, but that is going to take some bandwidth, right? And when you have a game that may run, 100,000 sessions every minute or whatnot, when you have a large sort of a multiplayer game, that way this naive sending of packets wouldn't just work. So you have to keep compressing your strings. So compress them before you send, and then of course decompress them back when you receive them. And always it's a multiplayer game, right? So hacks, there's a security issue. There are people always trying to game your system. So we can, as programmers, do the bare minimum, use some sort of a obscure packet, sort of data obscuring library to kind of hide your variables so that the players can't read, or some sort of some security researchers playing with our game or whatnot, and they're trying to hack, let's see, and they won't be able to read these variables. So if you kind of use these sort of data obscured data types, it's quite good, it's robust. Like we've seen the number of hacks kind of come down, the kind of values that may get tweaked do not get tweaked if you kind of have a structure like this. And of course, be smart about your data structures, like be very, very simple. Like as you've seen, I've used like a 2D array to kind of pack a data structure. And you can wrap your data in any sort of a custom sort of a solution. That way it works well. And it's small in size. So yeah, that was all about packet wrangling, right? Now, so there are many challenges, right, when you develop multiplayer games. And actually all your challenges that you may face would be, what do you mean? They are specific to the game that you're trying to develop. Sometimes it might be like a packet size issue, that you may need to work around your way for. Or it could be like a packet duplication issue. So that would be the times where, let's say I'm a player and then I said I got score of 5. And on the server side, I get the same packet again from supposedly me, which says I got a score of 10. Now, how do I trust? What do I do? So that is a kind of a packet duplication sort of a thing. It's a hack sometimes. Or it's just a packet failure, right? Packet manipulation also, a tweak to the value before you get the packet. So the server should never accept anything that the client says. Like, do not take it just like, oh, I like it. That you should never do that. You sort of always kind of validate, double check, triple check all sorts of packet and the data that you get from the clients. So to kind of deal with that, one sort of a technique that you may use is the use of a deterministic random number generator. So anything deterministic, I kind of get very excited about that because it's deterministic. That's the whole part of it, where given the same input, you'll always get the same output. So you could have sort of your own custom deterministic number generator on both the client and server, right? So like this example that I'm talking about here, well, let's say you have a dice, and I threw the die, and I have, it's a 6-sided die. So we get 1 to 6 numbers. Now instead of the client telling the server, hey, here's my die, I got a value of 5, 6, which is good, it works. But it's easy to kind of game that system if you really think about it. As a client, I can be like, I don't know, if I'm using some sort of an external app to kind of get the packet, maybe change the number and send it across. I don't know, it could be anything. This is like you can easily manipulate that. My die number can be 4 on the device, but then by the time the packet gets to the server, it could be 6 or something like that, right? So to kind of avoid dealing with issues like that, we can have a random number generator where you know that for a given input, it will always give you the same output, right? So you can have some sort of a seed value, maybe, and you can assign this sort of a random number to each of the die. So let's say your random number generator gives you 6 different random numbers. Instead of sending the actual die number from the client to the server, you can assign this sort of a random number. Let's say 1 would be 67 or 2 would be 100. And instead of sending that number, you can send this sort of a random number to the server. So that way, what would happen? Anyone reading the packet would be like, that number doesn't make any sense to me. I can't manipulate it. Even if you do manipulate it, we would know, right? Because on the server side, when I do get the packet, I can kind of look it up and be like, hey, given that input, this doesn't match. So there's something wrong here. I can discard that and move on with life. So what do you mean? On the server side, it's very important that you sort of validate everything, right? So with a random sort of a deterministic random number, of course you need to validate all your requests, right? But you don't need to validate it to the core to a point where you question everything, right? What is the timestamp? Where did the packet? Is the value correct? Am I calculating it correct? But instead of all of that, if you do have the sort of a generator, you can quickly validate, because the only way a player can see how that function works would be if they kind of decompile the code and kind of go through the code. So if you have the code embedded in your client and then you kind of on the fly generating it, it's easy, right? It's helpful because the copy of the code remains on the client and there's one copy on the server and no one else. So that works out well for you. So here is a small, this is the function that I've been using. It's pretty simple, pretty basic, but gets the job done. I can always get a sort of a deterministic set of list given the same input. So yeah, and of course, this gives you some sort of security, but it's a multiplayer game. You have to be careful when you use these terms, but this kind of guarantees that on some level you can get away without validating too much, just because you have the sort of a code-based sort of a validation. And one of the other techniques would be physics simulation, right? So you have all sorts of multiplayer games, mostly when you have simple turn-based games, which is fine. You know, you can send one packet, it's about sending one packet to the other, so it's just the basics. But then comes a time when you have a multiplayer game where it would require some sort of a physics. Let's say it could be any game, like a pool game or I don't know, side-scrolling football game where you have things moving, where you want to use some sort of a physics. So how do you replicate physics, right? So a player moved a, what do you call that, snooker ball in one client side. So you have a whole set of movements, all these balls hitting, moving everywhere. And then how do you translate all of that onto the other client? So the naive solution would be you kind of use Unity's physics, and then you have the same inputs to the same physics on the other client, and then you kind of do the same move. Most of the times it may work fine, but a lot of the times you will see that for the same sort of input, for the same sort of a physics movement, both the clients would have drastically different simulations, right? Which is not ideal. So when it comes down to issues like that, you can use Unity's physics simulation mode, right? You have a whole library for that. Not library, it's part of the API that you can use, where you do not have to kind of rely on the whole physics to work out in real time. Rather, you can step through your own physics. You can, let's say if I do a whole snooker sort of a move, you can generate the whole physics movement data within one frame. You know, you can iterate through the whole physics simulation and then kind of accumulate all your data. So what I mean to say that before we start the simulation, you can kind of keep the simulation to the script mode, and then we run through the simulation. You have a max simulations iteration. Let's say you have 1,000 sort of a threshold, and you run it 1,000 times, and then you keep track of your time. You go through all of your physics elements in the game, and you do your custom update for that. You know, that way, what I mean by that is you can record your physics movement. So let's say for time t equals 0, you have a puck that is here, and then time t equals 1, you have it there. So you record it at every x time interval, and you accumulate all of this data. And you kind of, I was talking about having smart packets in the earlier slides, right? So you can accumulate all of this data, loop through your whole physics items, and you can pack them up, right? So you have your position, you have your y, z, the time, what object it hit on, and what objects did it collide with, and everything. And you can get a whole neat sort of a small data structure, make it into a JSON, compress them, send it across to your other client, and it's easy now. Life is easy because now you have a client receives what do you mean? There's no room for error. Right? I have a simulation data. My only job is to just re-simulate the whole simulation data, and now we have accurate simulations going on for both the clients. So yeah, multiplayer is quite hard. It's very tricky. You kind of, I still make a lot of basic mistakes, right? So you end up making multiplayer games, and you kind of start questioning life. Why did I break up? What's happening? It makes you frustrated. So it's tough, but I guess once you kind of get through your, the simple basic things, you kind of develop all of these things, and you have that ready, you can kind of focus on how to move forward, right? So you have, once you have all these systems, then it becomes less daunting. I remember being quite I get iced when I work on multiplayer games. Initially, I'd be like, oh, how am I going to do this? How am I going to do that? But then over the time, once all of these sort of headaches were kind of sorted, and I had the solutions for kind of, I became a happier person, I would say. So yeah, that's me. Thank you all.
Can we take some questions?
Yeah, for sure. I was just about to get to that.
Anyone?
So, of course, if you guys have any questions.
So can you explain tick rates? Tick rate.
Tick rates. So when you work on, are you working on a real-time sort of a game?
I'm not working on any multiplayer game. I'm still learning Unity.
So it really depends. It really depends on what kind of a multiplayer game that you're talking about. So you have turn-based game. So if it is turn-based, there's not really, you're not ticking, you don't have to process any requests X number of seconds, a second or whatnot. So, but then if you are really dealing with real-time games where you have multiple updates that are going on, then tick rate would just mean like the tick of your watch, but then this goes much faster. You can have a tick rate of 30 times a second. It's just like how your screen refreshes. You have a 30 hertz, 60 hertz. So a multiplayer game can have processed things for 30 seconds in a second or 60 seconds in a second. Games like, I don't know, what's that, Mortal Kombat and things like that, they kind of work on this sort of a tick rate, because you are constantly processing things and you need to know how many times a second the server is able to send messages through and, so that's that.
Does tick rate affects the performance of the game?
Yeah, for sure, because it really depends on how big a data that you're sending, how much of a data is there in one packet, and do you even really need that many ticks per second for your game?
If I am making a multiplayer game, like shooting game, so does tick rate is going to be very low or very high? Like
For sure, it's going to have to be very high, but then you need to see, like the new CS had come out, they have a tick rate and a sub-tick rate. I mean, these are all really more complex sort of a network systems. But yeah, for a multiplayer game and especially a shooting game, a tick rate is the soul of the game. So you have some games that run at 60, you have some games that run at 120 tick rates. But of course, that really depends on how much of a bandwidth that you have in your server, right? Like if you can you process that many requests, do you have that many players? How does your systems work well with that sort of a
so how can we handle it? Like if I want to make an like tactical shooter game, but I also want to keep my game optimized, but I have to, I want higher tick rates. So how can I, manage that?
fail first a few times, I guess.
Actually, I am making a game like that, and I'm lost it.
Yeah, well, you're me a few years ago.
Yeah.
But things will get better, but there's not really a particular solution. Like I mentioned, like all of these games, things are particular to your game and your needs. You need to see how your code is set up and what is the kind of ideal tick rate that you can have so that your game kind of runs well. So it's not like a black or white sort of a scenario. It's gray.
Okay.
You need to see what works well for you all.
We'll take one more last question.
Yeah.
So,
So he'd.
Hello. Let's take a car game basically, which you made yesterday, which I played.
Oh.
So you said the timestamps, right?
Yeah.
How do you replicate? Like how do you use timestamps in basic multiplayer games? Like at every area or checking with the other players regarding their.
So that it works a little differently, right? So the game that we are working on is a real-time sort of a game. If you think it's a car racing game.
Yeah.
So that doesn't use SmartFox. That uses something else, Unity's netcode. So Unity's netcode. So that's
Not Photon.
So I believe Unity uses Photon internally,
Okay.
but we are using netcode to get our things done. So they deal with timestamps a little differently. These are things that we have to write for ourselves, right? But netcode and everything, they have a lot of these variables inside that they do not deal with timestamps like in the plain and simple way that I mentioned. It's much more complex and nuanced than that. There's a lot of...
Like how do you replicate them then?
So at least when it comes to netcode, we don't have to think about replicating this sort of a naive way.
Okay, it's totally.
Yeah, we have different systems for that, which deals with the physics and whatnot and how those things work. So it's,
Okay.
yeah.
I understand. Thank you.
Well, thank you so much,
All right,
Ashwin.
thank you.
We would like you to stay back. We have a small goodie gift for you.